All right, so day 3, and again, our homework is section 7.3, page 841, and numbers 29 through 36. All right, let's take a look at an example. So we want a partial fraction of x minus 20 all over x plus 3 times x squared plus x plus 2. So what is our partial fraction decomposition? Well, what we know is that when we have linear factors in our denominator, you're going to have a constant divided by all of our distinct linear factors. So that's going to be a divided by x plus 3. What we also learned yesterday is that for something like this, we tried to factor it into a product of linear factors. Well, what happens when you can't do that? So here we have a quadratic, x squared plus x plus 1. Can we factor that? No. So now we have a situation where we have a quadratic factor. We can't factor this into our linear. So here, we're going to write this over x squared plus x plus 2. But it's actually not going to be b. Because this is a quadratic, our numerator has to be linear. So it's going to be bx plus c. So with a linear factor 1 degree lower than a linear factor is a constant, for a quadratic factor 1 degree smaller than that is a linear factor. If we were to do partial fraction decomposition and you had a cubic on the bottom, then this would be bx squared plus cx plus d. You would always go 1 degree smaller. Now, once we have this set up, and by the way, we're going to write the rule for this after we do this example. But once we have this set up, everything else is done like we've done it before. So our two distinct factors, one linear, one a quadratic, we're still going to multiply both sides by that. So here we're going to have x plus 3 times x squared plus x plus 2 times 8x squared plus 12x minus 20 over x plus 3 times x squared plus x plus 2. That's equal to x plus 3, x squared plus x plus 2 times a over x plus 3 plus bx plus c over x squared plus x plus 2. So everything else that we've done before is still done the same way. Now here, as usual from before, denominator is completely cleared. So we're left with 8x squared plus 12x minus 20. That's equal. So for the first one here, the x plus 3 reduces to 1. So we're left with a times x squared plus x plus 2 plus, and with our second term here, it's the x squared plus x plus 2 that's reduced to 1. So we're left with bx plus c times x plus 3. Okay. So 8x squared plus 12x minus 20 equals ax squared plus ax plus 2a plus, now bx times x is bx squared, bx times 3 plus 3bx, c times x plus cx, and c times 3 is plus 3c. Now everything else gets arranged and grouped like before. So for our x squareds, we have an a plus a b. Is that the only one with the x squareds? So a plus b x squared. With our x's, we have an ax, a 3bx, and a cx. So that's a plus 3b plus c times x. And then finally for our constants, we have a 2a and a 3c. Are those our only two constants? So 2a plus 3c. Okay, now we're ready to generate our linear system. Yes?
Why do you write the x squared and the x after
My personal preference. If you want to write it before, go ahead. It's just that over here they're all written after. So here, the coefficient of x squared is 8. So we know that a plus b is equal to 8. The coefficient of our x is 12. So a plus 3b plus c is equal to 12. And our constant is negative 20. So that means that 2a plus 3c equals negative 20. And now we have a system of equations that we can solve. What we have to decide is which variable would we like to eliminate first. Want to eliminate c? Okay, so if we are going to eliminate c, then we can only use equations 2 and 3, correct? So equation 1, 2, and 3. So if we're going to eliminate c, 2 and 3. How are we going to go about eliminating c? Okay, so if we multiply the second equation by negative 3, so then that would be negative 3 times equation 2, and that's going to give us negative 3a minus 9b minus 3c, and that's equal to a negative 36. And then we're going to add that to equation 3, which is 2a plus 3c, and that's equal negative 20. Combine those. Negative 3a plus 2a is negative a. Negative 9b plus 0 is minus 9b. 3c's are 0. And then negative 36 minus 20 is negative 56. So this is our equation 4. All right, now what? Okay, so why don't we add equation 1 to equation 4? So equation 1 is a plus b is equal to 8. And this one works out nicely because your a's will, we don't have to do anything. If we just add those two, the a's equal 0. Negative 9b plus b is negative 8b. And that's equal negative 56 plus 8, negative 48. Divide both sides by negative 8. And we're going to get b is equal to 6. Now that we have b is 6, which one would you use, equation 4 or 1 to solve for a? Which one? 1? Okay. So if we use equation 1, then that's a plus 6 is equal to 8. So a is equal 2. Now all we need to do is solve for c. So here, which one of these, well, you can only use equation 2 or 3. Which one would you use to solve for c? 3? So if we use equation 3, then that's 2 times 2 plus 3c is negative 20. So this is 4. So if we subtract 4 from both sides, 3c is equal negative 24. And c, negative 24 divided by 3 is negative 8. So we ended up with a is equal 2, b is equal 6, c is equal negative 8. So going back to our original, so our original problem, it was 8x squared plus 12x minus 20 over x plus 3, x squared plus x plus 2. So that's equal a divided by x plus 3. So 2 over x plus 3. Plus bx plus c. So plus 6x minus 8 over x squared plus x plus 2. So that's our solution. All right, so for those of you who are working the elections, we did end up changing the homework. So the homework is page 841, and we changed it to 29 through 35 odd. All right, so we're going to take a look at one example. All right, so 3x squared minus 2x plus 8 divided by x cubed plus 2x squared plus 4x plus 8. Now, the first step is to always try to completely factor your denominator. So my question to you all is this: can the denominator be factored? Yes. We're used to factoring where you have 3 terms. Here we have 4. All right, so take a look at our denominator. I'm going to group it. What's our greatest common factor in my first set of groups? X squared. So if we pull out an x squared, we're left with x plus 2. Plus, what's the greatest common factor in the second set? 4. We pull out a 4, we're left with x plus 2. Now we're going to use our distributive property. So we can pull out an x plus 2, and we are left with an x squared plus 4. So we are able to factor that. X cubed plus 2x squared plus 4x plus 8 factors into x plus 2 times x squared plus 4. So this can now be rewritten. The x plus 2 is a linear factor, so that'll be a divided by x plus 2, because it's to the first degree. The second factor is quadratic, so that'll be plus bx plus c over x squared plus 4. The x squared plus 4, you cannot break that down anymore. If that were x squared minus 4, we'd go x minus 2x plus 2, and that would make it linear. But x squared plus 4, we can't factor anymore. Okay? So now, we're going to multiply both sides by our LCD, which is x plus 2 times x squared plus 4. And on the left-hand side, when we do that, we're going to be left with 3x squared minus 2x plus 8. So on the right-hand side, we're multiplying by x plus 2 times x squared plus 4. We'll be left with a times x squared plus 4 plus bx plus c times the x squared plus 4 goes away, and we're just left with the x plus 2. So there I kind of cheated without writing out all of the steps. Okay, distribute. 3x squared minus 2x plus 8 equals ax squared plus 4a plus bx squared plus 2bx plus cx, and then plus 2c. Okay, let's group. We got an ax squared, a bx squared. I think those are only two. So a plus b x squared. We have a 2bx and a cx. So that's 2b plus c times x. And then our constant, we have 4a and we have 2c. And that's equal to 3x squared minus 2x plus 8. Okay. So we do have an x squared on the left. So the coefficient of x squared is 3, so that means that a plus b is equal to 3. The coefficient of our x term is negative 2. So that means that 2b plus c is negative 2. And finally, the coefficient of our constant is 8. So 4a plus 2c is equal to 8. So that's the linear system we need to solve. So we just have to decide which variable we want to eliminate first and go from there. Choose the... You want to eliminate the c's? So if we eliminate c, then we can only use equations 2 and 3, correct? And if we're going to eliminate the c, then we're probably going to multiply equation 2 times negative 2. So negative 2 times equation 2, that gives us negative 4b minus 2c. Negative 2 times a negative 2 is a positive 4. And then we're going to add just equation 3. That's 4a plus 2c, and that's equal to 8. When we add these two, I'm going to write the a first. So it's 4a minus 4b. The c is equal 0, and that's going to equal to 8 plus 4 is 12. So we'll call that equation 4. Equation 1 only has a's and b's in it. But what are we going to eliminate on equation 1? B? So we need actually a negative 4, right? Or positive 4, sorry. So we'll have to go 4 times equation 1. So that gives us 4a plus 4b, and that's equal to 12. When we add these, we get 8a equals 24. So a is equal to 3. Okay, now that we know that a is equal to 3, 3 plus b is equal to 3. Subtract 3. And we're going to get b is equal to 0. And so now we need to solve for c. Equation 2 or equation 3? 2. Okay, so 2 times b, 2 times 0, plus c is equal to -2. So c equals -2. So our solution then, if we go back up here, our solution, a ended up being 3, so we're going to get 3 over x plus 2, plus b ended up being 0, and c is equal to -2, so it'll be plus a -2 over x squared plus 4, or 3 over x plus 2 minus 2 over x squared plus 4. So either one of these would be correct. Okay, ladies.